Okay, today we're going to learn how to multiply and divide and simplify radicals. Okay, that's what we're going to work today. We've actually done this before, so it's not that different. Like especially multiplying and dividing square roots, right? But But the part where people have most trouble is simplifying. So let's remember the rules. So an expression having square root radical is in simplest form when, okay, write this down. There are three things that we're going to talk about, so write this down first. When I'm sure a lot of you know this rule already. First one, no factors of radicand. No factors of radicand has a perfect square. Radicand has a perfect square, okay? Other than 1, okay? So does anybody know what I'm trying to say here? What does this mean? No factors of radicand has a perfect square. Okay, other than 1. Yeah.
The like the radicand, the factors inside the radicand has to be in like simplest form. It can't be perfect, like a perfect square.
Yeah. So like this, right? Square root of 8. Could I leave? Is this simplified? Square root of 8? No, because inside the radicand you have a factor of a perfect square, which is you got 4. Isn't this square root of 4 times rad 2? So you got to simplify that, okay? You know, we've done this before, haven't we? So you get 2 rad 2. So don't leave it as square root of 8. You know, then you don't get full credit, would you? Okay, so you get, when you simplify square root of 8, you get 2 rad 2. Okay. Any question? Second rule is this: no fractions are under a radical sign. Okay, write this down. So for example, could I leave, is that simplified? Square root of 3 rad 4 or something like that? No. See, you got a fraction under a radical sign. You can't do that. How do we simplify this? Yeah.
Square root of 3 over square root of 4.
Right. Square root of 3 over square root of 4, which is square root.
The square root of 3 over 2.
Yeah, square root of 3 over 2, like that. Okay. So you cannot leave the whole thing under square root. Okay.
Still pass.
I'm sorry. Okay. And kind of goes along with this. We actually did this. Can you think about the third rule? This kind of it goes along with the second rule. Can somebody think of? Yeah.
There can't be any radical signs on top.
That's right. Very good. And no radicals are in the denominator. So, remember? Could I leave it like this, like 2 rad 3, something like that? Is that simplified? No. So how do I fix this? Do you guys remember? One person? Come on. Yeah, Peter. What do I do? Where? You're right. Top and bottom. To numerator and denominator. Because after all, what is square root of 3 over square root of 3? 1. Okay, so it doesn't change the value of that fraction, but it does get rid of that denominator that has radical, right? So you get 2 rad 3 over 3. Do you guys remember this?
Yeah.
Okay, so we've dealt with these. We're kind of reminding ourselves how to simplify these. Okay. Any question? We'll have our quiz on this on Thursday. Okay. Next week. Yep, Thursday. All right. So knowing this, by the way, there's a name. We call this something. You know how we had a denominator? What kind of number was this denominator? This rad 3. Oops. What kind of number was that, guys? Is it a rational or irrational, that rad 3? It is irrational. Now, look at the denominator. Is it a rational number or a irrational number? So, do you guys remember what this is called, this process where you multiply, you get rid of the square roots in the denominator? Yeah, Sasha. Rationalizing the denominator is correct. Very good. It's called the rationalizing the denominator. You guys remember? So you may need to know what that is because I may ask you to, like on the test or homework, it could say rationalize the denominator. And if you don't know what that means, you're not gonna get it right. So you have to know what this is called. Okay. So it's easy, right? You're making irrational denominator into a rational number. Okay, that's what we're doing. Okay. Any question? Okay, so we're ready to now do some examples. Now, what if I give you example 1? Simplify. 5 rad 3 times 8 rad 21. If I gave you something like this, what would you do? Okay. Go ahead. You guys try. Anybody have any idea? What should I do first? Yeah, one person knows. That's it. Come on. How do we, guys? Yeah, Jeffrey.
You multiply?
Yeah, yeah. So how do we do that?
The first you multiply 5 and 8.
Yeah, 5 and 8. Is it okay to multiply 5 and 8 first? What property tells you that you can move around when you're multiplying things? Commutative property of multiplication tells you could do this. Right? 5 times 8 times rad 3 times rad 21. So you guys remember the rule, if I have square root of A times square root of B, what's this? Square root of AB. Or you could go the other way around, depending on how you want to, simplify. So do you think I want to use this rule at this point? Yeah, kind of. But before, so you think I should multiply 3 and rad, 3 times 21 under the rad? But no, I don't want to do that. Why not? Yeah. Yeah, I could simplify the square root of 21. Remember, that has a perfect square of what? What does 21 have? Yeah.
3 and 7.
Huh?
3 and 7.
Yeah. Well, it doesn't have a perfect square. I'm sorry. It is square root of 3 times square root of 7. That's right. So why do you think I want to write it that way? It doesn't have a perfect square. I said it wrong. Sorry. So you could rewrite square root of 21 as square root of 3 times square root of 7. Sasha, why?
Because then it would be 3 squared.
Yeah. Then what is square root of 3 times square root of 3? Square root of 3 squared. Isn't that right? I did a little factor tree for 21. You see? You don't want to rush into multiplying these radicals, right? Because you have to do a factor tree anyway. Why not simplify? Why not write it this way? Because I noticed 21 had a factor of 3, you see? And I knew that I could get those two things together. And so then this becomes simply 40 times 3 times, not 7, rad 7. So the answer, of course, is, yeah, 120 rad 7. Does that make sense? So don't rush to multiply the radicands together, because you're going to have to do a factor tree anyway, right? Why not kind of leave it and then see if it simplifies like this? Okay, it's better that way. Okay, any question on example 1? Is this a nice review? We've dealt with this before. Okay, good. All right. May I go into example 2? Oh, this one I should have written down. We actually did this, right? Square root of AB is really what? We use this rule. Square root of AB is square root of A times square root of B. That's what we use to do this part right here. Right, from here. Anyway, but we could do square root of A times square root of B is square root of AB. We could use that rule too. For example, here, if I have square root of 10 over 3 times square root of 27 over 32, anybody have an idea what we should do first? Hint, look at this rule. Oops. Tina.
First you put the radical on 10 and 3 and then 27 and 32.
Yeah, all of them in the
Yeah.
radical sign. Is that okay? Why should I do this? Why does it help me? Why would I want to do this here? Yeah.
Because that way you can simplify within itself.
Yeah, you could simplify within itself. I like how you said that. Inside the radicand, look at all these fractions, right? Doesn't 3 go into 27?
Yeah.
Doesn't 10 and 32, doesn't 2 go into 10 and 32? So you could simplify inside the radical. It makes it easier, right? So everybody go ahead and try, see what you get. Do you think it's a good idea to multiply the numerators and denominators first? No? If you could simplify first, you should do that. All right, who could tell me what I get when I simplify? 2 people? Anita, what do I get? Oh, you multiply them out. So first, okay, so you're right. But did you cancel that out this way, right? Yeah. The 3 and 27, right? 3 goes into 3 once, 3 goes into 27 9 times. And then, 2 goes into 10 5 times, 2 goes into 30. So you multiply the numerator. Should I do that? Should I multiply 5 times 9 for the numerator? Why not? The 9 is a perfect square. You see, if it wasn't, then yeah, you multiply it out. But since you have a perfect square, why not leave it as rad 5 times rad 9 over rad 16? Because we know square root of 9 is 3, square root of 16 is 4. So there you go. You know. So
You got it right.
good. Okay. So don't rush into multiplying. If you see a perfect square, you know it's going to simplify. Okay. So any question? Yes.
Can you,
Yeah, a lot of people ask me that. Could I write this as 3 over 4 rad 5? Yeah, but normally they don't write it this way. What's rad 5 really? Rad 5 over?
like one?
Over 1. So we want to write this the whole thing as 1 under 1 fraction.
Oh.
So it's better to read it this way. Okay? Yeah, normally we don't write it this way like this. Okay? All right. May I give you the? May I go to the next one? Okay. What if I have this? Square root of 75 all over 2 rad 18. Okay. So what should I do here? Do you think it's a good idea to put? Okay. So anybody have an idea what should I do in this case? Jeffrey?
You should start simplifying the square root.
Yeah, simplifying the square roots. Because does this, okay, this is really, okay, if you want to think about this, this is 1 over 2 times rad 75 over rad 18, right? So just like the previous example, do you think this helps us if I do 75 over 18? Does this help me?
Yeah.
It does? It does? Okay, because you could divide top and bottom by 3 too, right? But if you didn't see that, that's okay, right? You just simplify the radicals, and you do a factor tree for 75 and 18, right? Hello? Okay. So if you didn't see this, because if you did this, it's a little bit easier, but it's okay. If you didn't see that, that's fine. Just do a factor tree for 75 and 18, and I get 2 5s here and rad 3 for 75, and 2 3s for 18 and rad 2. Yeah, so I get. So what does this become, Brian?
5 rad 6 over 6.
5 rad 6?
5 rad
5 rad 3. Don't you mean 5 rad 3? Because 75 is 5 times 5 times 3, isn't that right? So you get 5 rad 3 over 2 times 3, which is 6 rad 2. Okay? Are we done? Is this the answer? Why not? Okay, raise your hand. Why not? Stephanie? Yeah, there's a radical in the denominator. You may not leave the square roots in the denominator. So how are we going to get rid of this radical? Yes, multiply with what, Jennifer? Yeah, multiply top and bottom by rad 2 over rad 2, right? Which is just 1. So it doesn't change the value of this fraction. It just gets rid of the denominator, the square roots. We're rationalizing the denominator here, right? So the answer becomes 5 rad 6 over 12. Does this make sense? 12, right? 6 times 2 on the bottom. Right. What is rad 2 times rad 2? Isn't that just 2? Right? That's how you rationalize the denominator, right? See? The square root goes away, but I mean the number is still there. Just it becomes 2 instead of rad 2.
Well, also you think you're just the square root of 2 times the square root of 2 is the same thing.
Right. It's 2. Square root of 2 times square root of 2 is square root of 2 squared, which is 2. Any question? Does this make sense?
Yeah.
Yes? Pretty simple? Okay, you guys try this one then. Go ahead. So did you all make it into an improper fraction first?
Yes.
Okay, and then I put everything under the whole thing because I noticed, does 4 go into 8? Yeah, so it makes it a lot simpler, right? So I get square root of 10 over rad 3. I'm done, right? No. Okay, you're not done because you have a radical in the denominator, right? Okay, so Molly, what do I do here? Yeah, multiply the numerator and denominator by rad 3. You get rad 30 over 3. How many people got rad 30 over 3? Raise your hand. Good. Any question? If you didn't, any question? Yes.
If it was rad 30 over rad 3, would it become rad 10? Rad 30 over rad 3? I don't know.
Yeah, if it's rad 30 over rad 3, yeah, that is rad 10 because it's really.
And now, so you can't
Yeah, you can't. Yeah, very good. You cannot simplify this 3 and 30 because the 3 doesn't have any radical. But if it did have a radical, you're right. Then it becomes rad 10 because it'll be whole thing radical 30 over 3, which is rad 10. Right? Good. But this is different. You realize this is different, right? Guys, do not cancel out 3 and 30, okay? 30 is inside the radical, okay? You cannot cancel because that's wrong, okay? All right. Now, we're going to now multiply. This is